All right, so now that we've learned how to solve some inequalities, let's find some compact ways to express our answers. So in a previous problem, we had noted that either x was going to be less than 4 or x was going to be greater than or equal to 9. All right. Now these are perfectly valid ways to write solutions down, and if that's how you want to write them down, this is one way to write them down. But there's another notation that we call interval notation that basically covers all the values between the points. So if we were to imagine that we were on a number line and we started at A and we went all the way to B, for example, we could imagine what it means to express all the values in between. Okay? Now, if we want to go ahead and include the point B, but we do not want to include the point A, and we express that by filling in the dot at B and leaving an open dot at A, well, what we're saying at this stage is we're asking for all the values of x between A and B, including B. All right? So that's one way to express this interval. Another way to do it is with interval notation. And the way we write that down is we move from left to right by writing the lesser values to the greater values. So if we look at this, the lesser value is A, so we start at A, then we include a comma, and then we go all the way to the larger value B. Now, when we write this down, we include around parentheses when we do not include the endpoint. All right, so anytime you see a round bracket like that, then that's what we mean. And then we include a square bracket. That means we do include. All right. So this is how we would express different intervals. So for example, if I wanted to express all the numbers between -3 and say pi, including pi, then I could write down that interval as round or open parentheses, -3, comma, pi, square or bracket, however you want to refer to it. All right, so that would be one possible interval. If we included both the endpoints, for example, then we would just simply write that down as A, comma, B, where we have square brackets because we include both the A and B. And we could also write this down, maybe possibly with both open. And this would be all the numbers between A and B, but not including A and B. And we'd write that down as AB. All right, it's all the values between A and B, not including A and not including B. Now, if you look at this, you would think, well, I've seen that before, but not as an interval, but as a point. Now, I'm just going to give you a notation warning. Intervals without endpoints are expressed the same as coordinates. So if you look at this, this could look like the point A, comma, B if we were on the x, y coordinates. But if we look at this, this is not what we're talking about. We're talking about all the values between A and B, not including B. So anytime you run into notation like this, it's always good to ask yourself, what do they really mean? Are we talking about the interval that goes from A to B, or are we talking about the point on the xy axis that includes the x coordinate A and the y coordinate B? Okay? So if you get confused by that, that's okay. We use the same exact notation for both those things, but it's good to just keep in mind what you're doing. If you should get a solution that's an interval, then you need to make a note of that and you should be writing down the word interval. And if you're referring to a point, you should make it clear that you're referring to a point in the xy plane. All right, so those are for bounded intervals. That is, intervals that have a left endpoint and a right endpoint. If we looked at this expression, for example, we would have 4. We would put an open circle because we're not including 4, and then we would go all the way to the left. This really doesn't put a stop on us in any way. And likewise, if we look at this is telling us to start at 9, include the 9, and keep going right. So how do we express these correctly? Well, the way we do that is we include the use of infinity, as well as negative infinity. Now, infinity is not a number. You can't add infinity. If someone says infinity minus infinity is equal to 0, that's actually not a well-defined statement. But what we talk about when you say infinity is it's something that keeps getting bigger and bigger and bigger. It just goes on and on and on. So when we talk about positive infinity, we mean keep going in the positive x direction. And when we talk about negative infinity, we talk about keep going in the negative x direction. So if we wanted to express something like x is less than 4, well, where do we start? Well, we keep going that way. Well, what do you mean we keep going that way? Well, we start way over at negative infinity because there isn't anything that stops us on the left side over here. And then we go all the way to 4. Now, if we look at this, we can't include 4, so we go ahead. We cannot include 4, so we put a round bracket to say that 4 is not included here. And if we look at negative infinity, which one do we put? Do we put the square bracket or do we put the round bracket? The correct answer is the round bracket. Because when we're talking about solutions, we're talking about all the numbers that we can use. And negative infinity is not a number, it's more of a concept of whatever is at the far, far end of that side. So we'll always do a round bracket when we see infinity. Now, if we do something similar with x is greater than or equal to 9, we start with the leftmost point, in this case 9. We write that down. We know it's included, so we do a square. And then we notice that we keep going right and right and right and right and right. And by a similar logic, we go ahead and we go to infinity. That is, we keep going right. So if we were to sort of think about what infinity and negative infinity mean, positive infinity means keep going right on and on and on. Negative infinity means keep going left on and on and on. And so that's how we express these two intervals. Now that expresses each of these things separately, but if we recall, the solutions were either this or this. So what do we say when we want to glue these things together? Well, we use the idea of a union. And what this does, pardon me, so in this case, what it means is we're going to take the interval that's all numbers less than 4. We write that down as negative infinity to 4. And the symbol that we use is a capital U. And that capital U basically means union. And then we need to glue to it 9 to infinity. And what this is saying is that my solutions, or my choice of all x's, can be between negative infinity and 4, which means that they're just less than 4, or they can be greater than or equal to 9. And this is how we do glue intervals together. As sort of a notational thing, we always like to read from left to right on the number line. So for example, if you were to write something down like this, this looks a little awkward because it's saying start at 9, include 9, keep going off to the right, and you can also include everything starting from negative infinity all the way to 4. And if I look at this, this feels backwards. You're basically taking this interval and affixing it to the other side over here. And that's a little tricky to read. So for notation's sake, you should be writing things in the left to right order. So going back to our nonlinear inequality, this would be one way to write the solution in interval notation. And while this one is correct, it's difficult to read and it's generally not preferred as a solution.